So let's start. Okay, so we'll start. Just give me 1 second. Okay, so first we'll see what is hypothesis testing. So basically, as you can see the definition, statistical hypothesis is an assumption about a population parameter. Okay, uh, like what can be different population parameters? Okay, like there could be um, like what is the average like lifespan of the people in a country. Okay, so this is one of the population parameter, or we can say that what is the average height of people in like Andhra Pradesh, what is the average height of people in like Uttarakhand, UP. Okay, so these are different population parameters, and why we are calling it as assumption? Any idea why we are calling it as assumption about a population parameter? Okay, because it is very difficult for me to like go to the whole population, go to every individual and calculate the okay like calculate the like status the values. Okay, so that's why we do sampling, and then we calculate that population parameter. Okay, so that is why it is known as assumption. Now this assumption may be true or may not be true. Like it is obvious, assumption, we cannot guarantee anything about an assumption. All right, and hypothesis testing refers to the formal procedures used by statisticians to accept or reject a statistical hypothesis. Okay, so whatever analysis that I have done, okay, whatever population parameter that we have calculated, that may be true, that may be false. Okay, because I have like I'm not 100% sure about it. Okay, so for testing the validity of that okay value, okay, the population parameter, for that we will be using this hypothesis testing. Okay, so like these are some of the population parameters. Okay, these are some of the population parameters that are there, like average lifespan of people or average IQ of a people in a country. Okay, so these are things in like okay. Okay, so like what are the types of statistical hypothesis? So first is null hypothesis, and the other is alternative or research hypothesis. Okay, so null hypothesis is the currently accepted value for a population parameter. Okay, and the alternative hypothesis is the hypothesis that needs to be tested. Okay, so by default we assume that null hypothesis is true. Okay, and if somebody does a research, okay, and it comes up with a value which is different from the value that is given by the null hypothesis, okay, so that thing we will call it as research hypothesis. Okay, so like uh, okay, so because we don't know that, like we assume that null hypothesis is true, we okay, that's why we do some more research. Okay, that's why we do some more research, so that we can get to the like correct population parameter. Okay, so that's why we do the research, and then we challenge this null hypothesis. Okay, and using some like various types of like tests, we try to like reject this null hypothesis. Okay, So let's see what is a frequency distribution table. Okay, now suppose that I went to 100 people and asked them this question. Do you think Modi government did good job in its rule? Is Modi government doing a good job? Okay, so like there can be multiple answers. Some people will agree that yes, they have done a very good job. Okay, some people will say that like okay, they have done a okay work, you know. Some people will say that we are not sure about this. Okay, so these are different kind of answers that I can get. Okay, so what I will do, I will store the count of every response that I have got. Okay, so 20 people strongly agree, 30 people agree somewhat, 20 people are not sure, 15 people disagree, and 15 people strongly disagree. Okay, so what I have done, for every degree of agreement over here, I have calculated the total number of people. Okay, then what I will do, like this is known as my frequency distribution table. Okay, so after this frequency distribution table, we create a frequency plot. So here what happens that all the different values that I have got. Okay, like here what I got the different degree of agreement. So I will plot this strongly agree. Okay, so here strongly agree will come, and how many time it has occurred. So strongly agree has occurred 20 times. So strongly agree, and I will like make it up to 20. Okay, but here I have taken different like parameter. I have taken height over here. Okay, so I did, okay, I did this, I asked for the data. Okay, I looked for the data in some individuals, and then I found that there was one person whose height was 139. There were two person whose height was 145 centimeters. Okay, so that's why that's how we make a frequency plot. Okay, now my data. Okay, now what I can do, like I can like here I had the discrete data. Okay, this was the exact value that I was looking. Now what I can do, I can create a height range also. Okay, if it is less than, okay, less than 5 feet, if it is between 5 to 5.5 feet. Okay, so what will happen, that all the heights which are less than 5 feet, okay, I will add the frequencies of all those, okay, all those heights, and then I will get this number. Okay, so like this is the way we can like do the like this is one of the other way in which we can make a frequency plot. Okay, here what we have done, we have taken the range of height that we are finding. Now like if we do, if we make a frequency plot, okay, of the range. Okay, so how we make that, like the starting, okay, the starting of this curve, here we will define 65, and at the ending we will define the ending of it. Okay, so between 65 to 66 there are four people. Okay, between 66 to 67 there are three people. Okay, so in this way we make this frequency plot. Okay, uh, okay, so after this comes probability distribution table. Okay, so probability distribution table links every outcome of a statistical experiment with the probability of event occurring. Okay, so what we are doing, like I have got this data with me. Okay, now I have the frequency over here. Okay, so using this frequency table, I will calculate the uh, probability. Okay, I will calculate the probability of strongly agree. So can any one of you tell me what will be the probability of strongly agree over here? What will be the probability? Like if I want to know. that what is the probability of this term. Like I have the frequency, okay, I know that it is coming 20 number of times. Okay, so how can I calculate the probability? You know that probability is between 0 to 1. Okay, and what is the formula for probability? Okay, number of favorable outcome whole upon total number of outcomes. Okay, so what we will do over here, if I want to find the probability of strongly agree, I will do like this: 20 divided by, I will add all these numbers: 20 plus 30 plus 20 and all. Okay, I'll be adding all these numbers. In the same way, I will calculate the probability for all other. I will calculate the probability for all other outcomes that I have got. Okay, all other outcomes that I have got. So this thing, okay, this thing we will call it as probability distribution table. Okay, what we will do in the from the frequency distribution table, okay, I will convert these frequencies. Okay, these are the frequencies. These frequencies I will convert into the probabilities now. Okay, so like this is a simple thing, that we do. Now what we do from this probability distribution table, we can make a probability distribution function. Okay, now what happens that like first we'll see what is a probability distribution function. Okay, so probability distribution is a statistical function that describes all the possible values and likelihood that a random variable can take within a given range. Okay, so like no need to go into the like definition of this. Okay, simply I'll tell you what it is. Like here what has happened, that here I have some value. Okay, I have some value. For that value, uh, okay, I have found the probability of it. Like here, so I am describing the frequency of that. Okay, here this is a frequency distribution like frequency plot. But if I will convert this frequency into probability, okay, then it will become probability okay, probability distribution okay, function table. So what will I do? Like suppose if I go to any value, okay, if I go to any value, it will give me what is the probability of that. Okay, it will give me what is the probability of that outcome. Okay, but if you see over here, like suppose I want to know the, like if we take another example over here. Okay, we have for 139 we know, 145 we know. What about the probability of 140? What about the probability of 140? This I don't know. Okay, so what we can do using this frequency plot, okay, what we can do, we can like, this is one of the technique we can use to create a probability function. Okay, we will just join these middle points. Okay, these middle points of these like plot. Okay, we'll join them. Okay, so now what will happen, that for 140 also I will be able to calculate the probability of it. Okay, so okay, so that is the thing. Okay, so that thing is also known as probability mass function. Okay, for every outcome, okay, for every outcome, if I'm calculating the probability of it. Okay, so this thing is also known as probability mass function. So like see, this is the probability mass function, okay, of a outcome of a die. Okay, outcome of a die. है ना? So like what is the probability of getting 1 in a die? It is 1 by 6. है ना? Probability of 1 is 1 by 6, probability of 2 is 1 by 6. Okay, so this probability mass function, what it will do, it will take the value x. Okay, x is the outcome that I can get. Okay, my outcome can be 1 2 3 4 5 6. So this is the outcome that I will, okay, that can happen, and this function will convert this outcome into its probability. Okay, so in this case, in case of a die, the probability mass function would be 1 by 6. Okay, probability mass function would be 1 by 6. And okay, and let's see what is a random variable. Okay, now, like, we do experiment. Okay, from the experiment what happens, we get some outcomes. Okay, so whatever possible outcomes are there of a experiment, okay, so that is known as, that is defined by a random variable. Okay, now what happens that, suppose I toss a die, so I will get either heads or I'll get a tails. Okay, so what will I do, I will give heads a number 1. Okay, I will give tails a number that is -1. Okay, so these values, okay, that I give, okay, to a particular outcome, okay, this thing is known as random variable. Okay, so random variable is a variable whose values depend on the outcome of a random phenomena. Okay, so the experiment I will perform, and I will get some outcome. Okay, so what I will do, for every outcome I will assign a number like 1, 2, 3, 4. Okay, so these numbers that I'm giving, these numbers are known as my random variables. Okay, now let's see what is a probability distribution function. It is a statistical function that describes all the possible values and likelihoods that a random variable can take within a given range. Okay, so, like, what does this probability distribution function will do, it will give me the probability of a random variable. Okay, within a given range, or we can say it can give me for infinite range also. Okay, so here you can see that, if I want to find that, what is, like, if this is the x value, I want to find this probability of 3.5. I want to find the probability of this, so what will I do, I will just go over here and just see its value. So I'll say that the probability of 3.5 is zero point 0.3. Okay, so, like, what has happened, like, probability mass function is this. Okay, it will contain all the random variables and the probabilities of those variables. But in probability density function, what will happen, that I will get a continuous output. Okay, so I will be able to find the probability of any value. Okay, between, like, in this range. Okay, 3.5, 3.5 also I can find the probability. Okay, so that is the, like, thing in this probability distribution. Okay, so using this probability mass function, like, we can get the probability distribution function also. Okay, now let's see, like, what is a data distribution. Okay, data distribution is a function which shows all possible values of data. It also tells you how each value occurs. Okay, like, this thing is nothing but the frequency distribution, frequency plot that we saw earlier, no? So the frequency plot tells me the distribution of my data. Okay, the distribution of my data. Now you can see that this data is, uh, what we will say, this data is uh, right skewed, right skewed. This data is right skewed, this data is left skewed. Okay, so, like, let's see an example. Okay, suppose I say that the test, okay, I designed a test and that test was easy. Okay, okay, so suppose, like, I designed a, like, test for you for the subject of data science. Okay, I designed a test. Now, just give me 1 second. Sorry for the interruption. There was power cut at my place, so that's why I need to stop. So okay, so like I was asking you this question. Okay, suppose I made a test for you, and okay, I made a test for you. 1 second. Okay, I made a test for you, and that test is easy. Okay, and suppose the numbers, okay, the marks that you will be getting will be from 0 to 10. Okay, so there will be other numbers also, 1, 2, 3, 4, 5, 6. So what do you think that most of the people will get how much number? Like if the test I designed is easy, then what do you think that most of the people will get how much number? Yeah, come on, please, please tell. What do you think? Like, are you able to understand the question that I'm asking? That if I design a test and the okay, if I design a test okay, and the marks that you will be getting will be from 0 to 10. Okay, so obviously most of the people will get marks, okay, more than 5. Okay, so like that is pretty obvious now, because the test is easy. So everybody will be able to score good marks. Okay, so that means that people will be getting around, we can say, 8 marks. Okay, they will be getting, most of the people will be getting 8 marks. So in this case, what will be my distribution? My distribution will be rightly skewed. Okay, rightly skewed. Okay, so okay, so the people who are getting 8 marks will be the maximum. There will be maximum people who are getting 8 marks. Okay, and there will be like very few people who will get this 1 marks. Like if they haven't studied anything, then only they will get 1 marks. But most of the people who have studied, they will be able to get 8 marks. Okay, so that's why here this will be highest over here. Okay, now suppose if the test is hard now. Okay, now I have made a very hard test. Okay, so now what will happen? How will be the distribution? Like now how many people will get like what will be the average marks that people will be getting? What will be the average marks? Yeah, please tell, what will be the average marks that people will be getting?
Less than 5.
So now what will happen? Now the test is very hard, so people will be getting like let's choose a number. Okay, let's choose a number. That people will be getting, most of the people will be getting 4 marks. Okay, so my distribution would be like this. So this distribution is left skewed. Okay, the meaning of left skewed is most of the values, okay, most of the values will be lying in this part only. So the people who are getting 4, okay, those are the maximum number of people are getting 4. And like there will be only one person, okay, who is getting 8 marks. Okay, so the people who will be getting very high marks would be very less. Okay, okay, so that is the way the distribution will be made for a hard test or a easy test. Now like there are different kind of distributions that are possible. Okay, so this distribution was for easy or hard test. Like This you can see now, this is a right skewed. So this will be for easy test or hard test. Please tell. My data is rightly skewed over here. You can see now it is moving towards the right side. So in which case the peak will move towards the right side for the easy test or hard test. Okay, so it will go towards the right for the easy test, है ना? Because most of the people will be getting higher marks, and this will be for the okay, hard test. Okay, now like if I give you a test, like some people are finding it very hard, you know, some people are finding it some people are finding it very easy. So in this way, like the distribution will okay happen like this. And like this is also one of the distributions. This we have like already studied the normal distribution. Okay, so here what happens, we have no bias. Bias means that it will not be skewed towards any direction, not in the right direction, not in the left direction. It will be in the like it will be uh, the highest point will be the average. Okay, the average of the x values, okay, will have the highest probability. Okay, so like these are different kind of distributions that I can have. So if I roll a dice, okay, then the probability of every outcome will be 1 by 6. Okay, so here what will be my curve will be like this only. Okay, 1 2 3 4 5 and 6. Okay, and this will be 1 by 6. Okay, so this will be my like this is the probability mass function that I'm calling. Okay, if I join all of them, then I will call it as a probability distribution function. Okay, uh, like this Bernoulli distribution has only, okay, this is also one of the kind of distribution that we have. So it has only two outcomes. Okay, so that is either success or either failure. Like suppose I toss a coin. Okay, so there are two possibilities, either heads, okay, or either it is a tail. Okay, so what is the probability for getting a head? What is the probability for getting a head? Okay, so I can call that head is success and tail is failure. Okay, so the probability of getting a head in a coin is 1 by 2, and here it is also 1 by 2 for probability of tail. Okay, so this thing will be true for the like unbiased coin, you know? If my coin is biased, then what will happen? If coin is biased, then suppose like I have heads on both the sides. Okay, so head is on the both the sides, the probability of head will be, what will the probability of head if it is a biased coin? Okay, so probability of head would be 1 na? Because like every time head will come, so probability of head will be 1 and probability of tail will be 0. Okay, so so these kind of distributions are known as Bernoulli distributions, where we have only two outcomes, success or failure. And we also have a Poisson distribution. So like Poisson distribution is also like this. Okay, like it's similar to like this, but the formula is different. Okay, for the Poisson distribution, like what are the different examples of like Poisson distribution? The number of emergency calls recorded in a hospital. Okay, so the number of calls, okay, emergency calls that a hospital gets. Okay, so what do you think, is it random, is it random or is it fixed? What do you think? Okay, so what happens that we can say that the number of emergency calls that a hospital will be getting Okay, that will be based on the average number of calls that hospital is getting in the past. Okay, now suppose the people are getting the hospital is getting 20 calls, emergency calls every day. So okay, like in the past, on an average they have got 20 calls every day. So that means that today also they will be getting around 20 calls. Okay, so for finding the probability, okay, whether the calls will be 20 or not, so there we will be using this Poisson distribution. So the number of thefts reported in an area. Okay, so no problem, no need to go into detail, but this is one of the distribution that we have. And also we have normal distribution. Okay, and it represents the behavior of most of the situations in the universe. Okay, so like here what happens that it is having the highest value, okay, at the mean. Okay, the mean will have the highest value, and the mean will be equal to mode, and it will be equal to median. Okay, and this normal distribution will not have any bias. Okay, that means it will neither be rightly skewed or neither it will be left skewed. Okay, and like what is standard normal distribution? Okay, if we normalize all the values of this x, okay, if we normalize all this value, okay, using the z-score formula, you know, x minus mu upon sigma. If I do like this, okay, for every value of x, then what will I get? Then I'll get my standard normal distribution. Okay, uh, and in standard normal distribution, what happens between mu minus 1 sigma to mu plus 1 sigma, we have 68% of the data. Okay, mu minus 2 sigma to mu plus 2 sigma, we have 95% of the data, and between minus 3 sigma to plus 3 sigma, we have 99.7% of the data. Okay, so this is one of the property that will be useful for you. Okay, and like t distribution we have discussed. Okay, t distribution happens when like, okay, when the sample size is less than 30. Okay, when the sample size is less than 30, then we will be using the t distribution. So like basically t distribution is like this is the standard distribution. The t distribution, okay, it will also be, okay, it will also be unbiased. Okay, it will also be not biased. Okay, but what will happen that it's these tails, okay, these tails will be like very, okay, in the upward side compared to the normal distribution. Its tails will be little bit upper. Okay, like you don't need to go into this. Like t distribution only then we will use when the number of samples are less than 30. Okay, if numbers of samples are less than 30, then we use the, then we take the help of t distribution. Okay, and you know that how do we calculate the z score? Okay, so that is x minus mu by sigma. Okay, so that is the formula for finding the z score. Actually, what is a z score? Okay, it is the normalized value, okay, of the random variable. Okay, okay, normalized value, okay, of the random variable. So what is my random variable? What is my random variable in this equation? What is my random variable?
X.
Yeah, yeah, x will be my random variable, no? So for every random variable, okay, I will like standardize it. Okay, and then we will get this z score. Okay, and like we have also seen like z score normalization in machine learning, no? So it is basically used, okay, for like standardizing, okay, the the like these x values that I have. Okay, now what I like, suppose we have a curve. Suppose we have a curve. So I want to find the area under the curve from this part to this part. Okay, so how will I do that? And the equation of this function is fx. Okay, so how will I find the area from a to b? How will I find the area? We'll do the integration, no? We'll do the integration from a to b. Okay, fx dx. Okay, fx dx. But like, you don't need to remember this formula, okay, this integration. But I want you to understand, like, in probability distribution function what happens. Okay, in probability distribution function what happens, that I have the probability. Okay, I can find the probability for any value. Okay, I can find the probability for any random variable. But if I want to find the value, okay, if I want to find the probability for the ranges, if I want to find the probability that the value will be between -1 to +1, okay, then what I need to do, then I need to find this area. Okay, then I need to find this area. Okay, so like, that's where this area under the curve becomes important, so that's why I have included over here. So now we have a like simple question. Okay, let's see, like, what is the question. Okay, so Molly earned a score of 940. Okay, in a test. Okay, in a test she got 940 marks. The mean test score was 850. Okay, so mu was 850. Okay, with a standard deviation of 100. Okay, standard deviation of 100. What proportion of student had higher score than Molly? Okay, assuming that the test score is normally distributed, there is a normal distribution. So can you tell me how will we find this? Like, she has got 940 marks. She has got 940 marks, but the average is 850. Like, I'll don't focus on the answer part. Okay, suppose this is a normal distribution. Okay, this is a normal distribution. All right, and here what will come, 850 or 940? In the middle, 850 will come, because this is the mean that I have, and she has got a value 940. Okay, so the question is asking, what proportion of students had a score higher than Molly? Okay, what proportion of students had a score higher? Like, here proportion, you can think of it as a probability. Okay, what is the probability that student will get more marks than 940? So can you tell me how will we do that? Any approach? Like, I will give you a hint. We have to find the area under the curve. Now, which area we need to find? Just tell me that. Which area I need to find as per the question? Okay, we need to find this area. No, but we need to find that the probability of a student getting marks more than 940. Okay, probability that he will get marks more than 940. So this is 940, है ना? If I find the area from this 940 to this entire curve, okay, and I find this area, then I will get that probability also. Okay, so can you tell me how will we do that? How will we find this area? How will we find this area? Yeah, please tell, how will we find this area? Okay, like we have seen the z table, na? We have seen z table. Okay, so using the z table we need to find the area. Okay, for this value, you know, we will find the c value for this random variable. What will be the z value for this? Please tell, what will be the z value for this 940? How will we convert this into z? Please tell, what is the formula for z value? I told you, right now only it is x minus mu by sigma. Okay, so what you do, you find this z value. Okay, then you uh, go into the z table. You go to the z table. Okay, then you find the value for this z. Okay, and then you will get this. Sorry. Then you will get uh, this area or this area. If you look into the z table, which area you will be getting? Okay, so if you look into the z table, then you will be getting this area. Then you need to subtract that area by 1, so then you will be getting the answer. Okay, so like that's the way we'll solve this question. Okay, now let's see some more things. Like we have type 1 error. Okay, so whenever we are doing hypothesis testing, we can like do some error also. Okay, so what errors can happen? That if, okay, I reject a null hypothesis, if I reject a null hypothesis, okay, but in reality, okay, it is true. Okay, if I reject a null hypothesis when it is true, that is known as a type 1 error, है ना? And the type 2 error is when we reject a null, when we fail to reject means that okay, we accept the, fail to reject means we are accepting the, which hypothesis we will accept. Like what is the meaning of this statement, fail to reject a null hypothesis? Come on, please tell. If null hypothesis has failed, that means alternate hypothesis we have accepted, na? No, alternate hypothesis we have type 2 occurs when the search fail to reject. Okay, fail to reject. Okay, so that means it is accepting a null hypothesis. Okay, but it is false. Okay, we are accepting the null hypothesis even though it is false. Okay, so this thing is known as type 2 error, no? So like if I ask you a question, okay, suppose my null hypothesis is that a person is corona negative. Okay, by default I'll say a person is corona negative. Okay, now I did the test, okay, and I found that person is corona positive. No? I, I found that the person is actually corona positive. So what do you think? Which kind of error is this? Type 1 or type 2 error? See, null hypothesis is that the person is corona negative. Okay, but in reality he is corona positive. So what kind of error is this? Type 1 or type 2 error? Yeah, please tell what kind of error is this? Type 1 or type 2? Okay, so it is a type 2 error. Okay, we are accepting a false null hypothesis. So that is the thing. Okay, uh, Also we have a term which is called as standard error. Okay, so standard error is an estimate of the standard deviation of the population. Okay, so like what happens that I will have some mu. Okay, this mu will belong to my population, you know, this mu will belong to the population. Now this mu will have some error also. Okay, it will have some error also, plus minus some error. Okay, so this error, okay, this error I call it, this is known as the standard error. Okay, suppose I say that in India a person average lifetime is 70 years. Okay, but this is not absolute na, है ना? This is not absolute that a person will be living 70 years only. There will be some like margin over here. Okay, so I will say plus 10 minus 10. Okay, but that means that a person life can be from 60 to 80, no, 60 to 80. So here what I'm saying that plus minus 10 is my standard error. Okay, so this thing is known as the standard error. When I'm finding the error with respect to my population. Okay, this thing is known as standard error. So let's see what are the steps for hypothesis testing. Okay, so first what we do, we take we specify what is my null hypothesis and what is my alternate hypothesis. Then what we do, we select a significance level. Okay, and in third we identify the test statistics. Okay, after that we formulate a decision rule. Okay, so like these are the main steps, these are the main step. Like take a sample and arrive at a decision. Like this is this part, like we don't need to include over here. Okay, so by doing this four step we'll be able to say that whether we have to like reject the null hypothesis or we don't have to reject the null hypothesis. So I will tell you, okay, the meaning of every statement over here. Okay, so the formula for standard error is sigma by root n. Okay, sigma by root n. N over here is the sample size that I am taking. Okay, the sample size that I am taking. So what happens that like I will ask you one question. If the sample size that I'm taking, okay, if the sample size that I'm taking is large, okay, then what do you think, should my standard error be high or low? See, if I'm doing the test, okay, if I'm doing asking the people, more number of people, then what will happen, my error will reduce. That means that I will come near to the actual population mean. Okay, so the same thing is happening over here, that if the value of n increases, if the number of, okay, people in my sample increases, then the error, okay, the standard error will decrease. Okay, so let's see like what is a critical value. Okay, um, critical value, okay, separates, okay, okay, is a line on a graph that splits the graph into sections. One of or two of the sections is the rejection region. Okay, so what happens that the critical value, okay, this critical value, this x value, okay, this x value, okay, what this does, it divides my this distribution into two regions. One region, okay, out of these two regions, one region is this and another region is this. Okay, so out of these two regions, one region will be the acceptance region. Acceptance region. Okay, acceptance of what? What I will be accepting? Come on, like acceptance of what?
Null hypothesis.
Yeah, acceptance of null hypothesis. No? And one area will be rejection of, okay, rejection of null hypothesis, okay, or we can say the acceptance of null, acceptance of alternate hypothesis, okay. So this value, okay, this value is known as the critical value, okay. Now comes the like test statistics, okay. So now what happens that I will take a sample, okay, I do my test on my sample, okay, and using this sample I calculate a like thing known as test statistics, okay. So here it is saying that a test statistic is a random variable that is calculated from the sample data and it is used in hypothesis testing, okay. So this is the formula for test statistics, okay. So x bar minus mu whole upon sigma by root n. So you can see that this is, what is this sigma by root n? Right now only we saw, no, this is the standard error, okay. And this t means if we are using the t distribution, okay, if n is less than 30 then we will use this formula, if n is greater than 30 then we will be using this formula, okay. So this is our test statistics. And like we'll see what is a confidence interval, okay. Like suppose like between these two values, okay, between these two values my null hypothesis is accepted, okay, my null hypothesis is accepted. So these two values, okay, okay, the interval, okay, in which my null hypothesis is being accepted, okay, that is known as the confidence intervals, okay. So here my confidence interval is between minus 1.96 to plus 1.96, okay. And if we find the area, okay, between these confidence intervals, then I will get the probability of null hypothesis to be true, okay. And that thing is also known as the confidence, okay. So this is a different thing, confidence and confidence intervals, okay. And the formula for confidence interval is this, okay, x bar plus minus z into sigma by root n, okay. So don't worry, we'll do some numericals, okay, then this thing will be more clear. But what I wanted to tell you that like just remember these formulas, okay, that we are studying, okay, like standard error and all these things, no? These things will be like helpful for you. Now we have different type of tests like one tail test, okay. Now what happens that this thing, okay, I will call it as critical value, है ना? This thing is known as the critical value, okay. What will I do first? Like I will set the critical value, okay. This critical value, okay, depends on the researcher, okay? It depends on the researcher where he want to set the critical value. Now what the researcher does, it does the test on the sample, okay. It does the test on the sample, then using then by doing the test on the sample it find a test statistics, okay. It finds a test statistics. Now if the test statistics, okay, falls in the rejection region, okay, test statistics falls in the rejection region, then null hypothesis will be rejected, otherwise it will be accepted, okay. So in one tail test what happens that we have only one critical value, okay, we have only one critical value. So okay, and this, okay, this thing is known as a right tail test, okay. If I'm on the right side of my mean, okay, okay, if my critical value is, okay, greater than my mean, critical value is greater than mean, okay, then for that I will say that it is a right tail test, otherwise I will say that it is a left tail test. Okay, so here what will happen, this will be my rejection region and this will be my acceptance region. Okay, so like left tail test, we have seen what happens. Okay, and like we'll also see what is a p-value. Okay, p-value indicates the evidence of a null hypothesis to be true. Okay, so what happens that if p-value is high, okay, that means that there is a more evidence I have that the null hypothesis is true. Null hypothesis is true. And if p-value is less, okay, what that means that there is very low evidence for my null hypothesis to be true. That means there is a high probability of alternate hypothesis to be true. Okay, if p-value is high, that means the null hypothesis, the okay, the probability of null hypothesis to be true would be very high. Okay, and if p-value is less, that means the probability of alternate hypothesis to be true, okay, will be very high. Okay, so what happens in p-value? Okay, p-value is basically like, suppose this is my test statistics. Okay, then I will find the area, okay, of this region, okay, where my null hypothesis, okay, will be rejected. Okay, I will find this area, so this is my area, and this thing, okay, this thing is the critical value. Okay, so I will find these two areas. Okay, so then we will compare, okay, the p value, okay, p value with the this area, okay, to the left side of the critical value. And if it is less than, okay, if p value is less than the, okay, alpha, we say this area, okay, to the right side of critical value, that is known as the alpha. Okay, so if p value is see, I told you na, if p value is low, okay, p value is low, lower than the alpha, if p value is lower than the alpha, then what will happen, my null hypothesis will be rejected. Null hypothesis will be rejected, that means alternate hypothesis will be selected. Okay, and in the same way, if p value is greater than alpha, okay, that means my null hypothesis will be accepted. Okay, so like this was the part of the presentation. Okay, now we'll see some numericals, then we will understand a little bit more, okay, about this hypothesis testing. Okay, so just give me 1 second. I'll connect. Just give me 1 second. Okay, now it is done. Okay, so like the things that we saw in the presentation, so it might not have made more sense to you, like if the concepts are not clear to you, so you may face problem, but don't worry, we will see we'll try to solve some problems. Then maybe things would be more clear. Okay. Now, what was the question that we had over here? Okay, just try to solve this question that we had. Okay, so Molly has got 940 marks, but the average is mu is 850 and the standard deviation is 100. Okay, so what it is asking probability that what is the probability of a person getting marks more than the marks of Molly. Okay, so this is what okay, so this is what the question is asking for. Okay, now what is happening that I will assume okay, the marks of all the students. Okay, here I have the marks. Okay, the marks of all the students is following standard distribution. No? It is following standard deviation and the mean is 850 you know, and standard deviation is okay, 100. Okay, now can you tell me how will we find like how will we find this probability that this is 940 no? And what I need to do, I need to find this probability. Okay, so what this area represent, this area represents probability of marks to be greater than 940 you know? So how will we do? First we'll find the z value. What is the formula for z value? Please tell what is the formula for z value. Yes, I. Yes, I. What is the value for like this formula for z value? Okay, so like it is pretty simple, na? X minus mu by sigma. Okay, so I will put x over here 940 minus mu is 850 whole upon sigma. Sigma is 100. Okay, in this way I will find the z value. Okay, so like what I have done. Okay, what I have done, I have standardized this. I have standardized this value. Okay, now okay, now basically the value will be between uh, like minus 3 to plus 3. Okay, so like 99.7% of my values will lie from minus 3 to plus 3 if I apply the normalization. Okay, so z-score normalization we studied, no? Z-score normalization. So that is the same thing that we have done over here. Okay, so can you tell what is the answer of this? What is the z value that I am getting? What's the z value that I am getting? Come on, please do the calculation. At least do the calculation. Z value is 0.9. Okay. Okay. Z value is 0.9. Now what will we do? We'll go into the z table. Okay, I'll show you. Let me go to the z table. We'll go to the z table. Z table, and we will see. Okay, we will see for z equal to 0.9. Okay. Z equal to 0.9, what is my value? So it is 0.8159. 0.8159. Okay, at z equal to 0.9. Okay. So what is this? This is the area that I am getting. Area from this area of this part, from this minus infinity to up to this region. Okay, so because this will work in the like standard normal distribution, so the z value is 0.9. So what the z table will give me? It will give me this area, and I want to find this area. Okay, so how will I find the area under the curve? What is the area under the curve? Whole area under the curve, like from minus infinity to plus infinity. What is the area? Okay, so that
One, sir.
area will be 1. Yeah, correct. It will be 1. Hai. From 1 we will subtract this 0.8159. Hai. So that will be my answer. So it is 0.19. This is the option. So the nearest one is 0.18. Okay, so this will be the answer, okay, of this question. Okay, so like that is the way we solve like this kind of question. Like, are you able to understand the solution that I've told you, or like you have any doubt in this? Because you were saying na, that you are facing difficulty in this. Like, if you have any doubt in any of the part, then you can ask me. Any step which is not clear to you, or any step where you are thinking that like why you have done this. All right, no problem. So we'll move forward. No? Okay, so let's talk some things about the z table. Like, I think I'll be asking you some questions, then only I will be able to get the picture. Okay, that whether you know the things or not. Okay, so suppose I have a z value. Okay, okay, and I go into the z table. Okay? I go into the z table, then I find for that z value. Okay, for that z value, I get this value. Okay, so what will this value represent? Will this value represent this blue region, or it will represent this yellow region? The value that will come out of the z table, what will it represent?
Blue region, sir.
Correct. Okay, it tells from the like left hand side. So okay, so that is the thing we do in the z table. Now let's see some things about the statistics. Okay, how we do like hypothesis testing. All the things that we have studied, I will be telling you once again. Now, like everything will revolve around this normal distribution only. Okay, so like why we call this a normal distribution? Like, does anyone of you know why we call this as a normal distribution? Like this name normal we are using. Why we say it as a normal distribution? Okay, so So the reason is that most of the events in the universe, most of the events that happen in the universe, okay, those events follow a normal distribution. Okay, like that's why it is calling a normal distribution. Like this distribution is very normal. Okay, in every event. Okay, every event. So what can be the events? Like what are the average heights of the people? Okay, for a particular population. Okay, so that will follow a normal distribution. Okay, like we take another example. Okay, like what will be the temperature? Okay, average temperature in a day. Okay, uh, okay, and we calculate the temperature for every day. Okay, है ना? So that will also follow a normal distribution. Okay, so this distribution is like frequently occurring in the universe. That's why we call it as a normal distribution. Okay, now what happens that I told you earlier, no? That I cannot do, like, suppose I want to find the height average height of the people in India, है ना? I want to find the average height of people in India. So I will not go to every person in India and ask him its height, because that's not possible for me. Okay, because like what is our population? Population is, I think, 130, 140 crore. So we cannot go to every person and ask him his height, take the measurement, and then give the value. Okay, that the average height of the people in India is this much. But instead of this, what will we do? We will take a sample of this population. Okay, so this is, suppose this represents the India. Okay, India population. So I cannot do the testing on the whole of the population. So what I do the testing on a sample of it. Okay, so this sample is very, like, properly taken. Okay, so in this sample I will not take people from only one state. I will take people from every state. Okay, and if I ask you that should I take equal number of people from small states also and large state also, should I take equal number of people? Like suppose there is I think it's a union territory, Goa. Okay, I'm taking two people from Goa, okay, in my sample. So should I take two people from, like, UP also? Should I take two people from UP only, or should I take more, or should I take less? Okay. So like this is Goa and this is UP. UP is very big compared to Goa, है ना? So I'm taking two people from Goa. Okay, so like I will take people as per the population. More the population, more will be the people that I will be taking from that state. Okay, so like that is a different story, that how we take okay, how do we take the sample from population. Okay, so like I will not go into the theory part of it, but I'm just saying that we take sample, you know? And why we take sample? Because we cannot do the testing on the whole population. Now what happens that for India, okay, like we would have done various tests earlier also. Okay, we have taken some sample, then we found some average height. Okay, so all the things that we studied earlier, okay, by looking at those things, we get that the average height of people in India is 150 centimeter. Okay, this is the average height of people in India. This is the thing, okay, that I assume it to be true. Okay, because in reality I haven't found the, you know, height of all the people. What I have done, I have taken sample and then found the area. Okay, then found the heights. So this is the commonly accepted value. Okay, that I think is true. Okay, now what happens that suppose, suppose I think that the average height has changed now. Okay, So like how do you think that the average height can change? Is it possible that average height of people can change? Like any idea? Like is it possible? See, let's take another example. Okay, that example will maybe make more sense. Okay, so suppose like Maggie. Okay, Maggie. Maggie is okay. Like lots of Maggies are produced in India. Okay, and they have what we say that ppm we say or lead. Okay, lead content. Okay, we think that the lead content in Maggie is okay 2.3. Okay, till now we say that the lead content in Maggie is 2.3. Now what happens that what Maggie, okay, like Nestle. Okay, this Maggie belongs to Nestle company, na? So what this company is doing now, now they are okay, now they are including more lead. Okay, they are including more lead in their Maggie. Now what will happen? Will the average, will the average change now? Okay, earlier it was 2.3. Now what is happening that frequently people like they did the test and they are seeing that the lead content is more than 2.3. It is 2.5, 2.8, 2.3, sorry, 2.9. No? So they are finding that the lead content is more. So by looking at these values, can they say that the Nestle company is like including like more lead? Can we say that by looking at these three samples? Okay, so like we cannot say that. Okay, so we need to do some testing, and using those tests only we will be able to say that whether it has actually changed or not, you know? So okay, so what happens that I told you the steps, you know, that are there for doing the hypothesis testing. So let's see the steps one by one, you know, so that it makes more sense. Okay, so first what we do, that we state the null and alternate hypothesis. State null and alternate hypothesis, है ना? So in this example, okay, what is my null hypothesis? When I was talking about the heights of the people in India, what is the null hypothesis?
mu equal to 150.
Correct. No? Mu equal to 150. And what would be my alternate hypothesis?
Mu is not equal to 150.
Does not equal to 150. Okay. Now if we see this example of the Maggie, you know, here null hypothesis is, okay, null hypothesis is that mu, okay, is less than 2.3, है ना? Why it is less than 2.3? Because like this is the upper limit. Okay, this is the maximum lead that they can put in Maggie. Okay, so earlier we were thinking that Maggie is, okay, the lead content in Maggie is less than equal to 2.3. Now what is happening that we are finding, okay, frequently we are finding that the lead content is more than 2.5, 2.3. Okay, so what will be my alternate hypothesis? What will be my alternate hypothesis? Okay, so lead content is greater than 2.3, mu is greater than 2.3. Okay, so this will be my alternate hypothesis. Now In this example of the average height of people in India, here what will we do? We'll do a two-tail test. Okay, see, I have a null hypothesis. Okay, so it is mu equal to 150. Okay, and what we will do? We will define, okay, a confidence interval. Okay, how much confident I am that this uh, okay, that the average height is between these two values. Okay, uh, okay, so let's do a numerical and then it will make more sense. Okay, so let's see the question. Okay, so we have wind speed. Okay, like we have also done this numerical earlier also, but we are trying to do this again. The wind speed is 9 miles per hour, and n equal to 36 days, and for n equal to 36 days, the okay, the like the average wind speed, okay, the average wind speed that we think, okay, in a place is 9 miles per hour. But a researcher came and then he did the test for 36 days, then he found the average. Okay, then the wind speed was 9.3 miles per hour, you know? And sigma, the standard deviation, is zero point 0.8 per hour. Okay, and we take this alpha to be 0.01. Okay, so what I need to find, I need to find whether, okay, this wind speed has changed from 9 to 9.3 now. Okay, after doing the testing, whether it has changed or not. Okay, so first what will I do? I will state, okay, the hypothesis. So can you tell me what will be the null hypothesis over here? Yeah, what is my null hypothesis? It's
Mu equal to 9.
equal to 9. Okay, so this is my null hypothesis, and alternate hypothesis. Okay, so alternate hypothesis will be mu does not equal to 9. Okay, so first we have defined the this hypothesis, this null hypothesis and alternate hypothesis. In second step, what I will do, I will select critical, I'll select the significance level. Okay, select the significance level. Okay, so significance level is given in the question, that is 0.01. Okay, so like what is the meaning of this 0.01? See, okay, I have this distribution. Okay, so mu is equal to 9 over here. Okay, and like, okay, this region, how much confident I want to be. Okay, this will be defined by the significance level. Okay, so can you tell me uh, what, okay, for what range, okay, of this x, okay, for what range of x, okay, I will be 100% sure, what range of x I will be like 100% sure that like the test statistics will lie inside that region. Okay, so see, if I take x, okay, from minus infinity to infinity, है ना? Then what will happen? Whatever on whatever sample I'll do the test, on whatever sample I'll do the test, okay, the results that I will get from the test, okay, those results will lie in this region only, okay, from minus infinity to plus infinity, है ना? So like in the same way, I define this region, okay, I define this region that up to which, okay, up to which uh, this values, okay, up to which values okay, my null hypothesis I will be accepting, है ना? So I defined a significance level. So basically significance level will be this part where my null hypothesis is not true, है ना? And this will be the area, है ना? I will define it by alpha, and alpha will be the area of these red regions, है ना? Alpha will be the area of these red regions. That means here my null hypothesis I will be rejecting. Okay, now I will, okay, find the third step is find the test statistics. So can you tell me this distribution, does this distribution belong to the population or the sample? This distribution belong to the sample or does it belong to the population? What do you think?
The population.
Correct. Okay, so this belongs to the population. Now, okay, I will calculate the test statistics for the sample, है ना? From the test statistics what I found that that the average, okay, wind speed is now 9.3. Average wind speed is 9.3. Okay, so what should I do? Should I accept this value? Okay, okay, so what happens that there will be some error in this, okay, there will be some error in this. That's why we use some other formula for finding the test statistics. Okay, okay, 1 second. Okay, see, like first let's try to solve this question using the critical value method. Okay, first let's try to find these critical values. Okay, what will be these critical values? Okay, so does anyone remembers the formula of the critical values? What is the formula for the critical values? Okay, so it is x plus minus z into sigma by root n. Okay, this is the formula for critical value, है ना? Now in this x bar I have, है ना? So sorry, this will not be x bar, this will be mu. Mu is my population mean. Okay, z we will see. Okay, this is my population standard deviation and is the size of the sample that I have, है ना? And this z value, okay, this z value will find using the significance level, okay, using these significance level. Okay, so can anyone of you tell me like how will we find this part, how will we find this part, this value? I know the area of this part, I know the area of this part, and I want to find the area of this, oh sorry, the value at this point. How will I find that?
So using the Z table
So how will we do that?
for the area we got, we have to check
Mhm.
for the points.
For the points now we need to see now. We know the area now. Okay, area is given by the alpha. So how will we do that then? See, the area of these both of these red areas. Okay, both of these red regions. Okay, is alpha. So what will be the area of only this part? What will the area of only this part? Okay, alpha basically contains the area of both these regions. है ना?
Alpha by 2.
This will be alpha by 2. So what is alpha over here? Alpha is 0.01. So 0.01 by 2, that is 0.005. So this is the area of this part. Now I want to find the this value. This value. So you said that we need to find this value using the Z table. So I'll open the Z table. Now can you tell me what will be that value? How will you find that value using the Z table? This is not the proper Z table. I'll open the proper Z table. Yeah. Can you tell how will we find the Z value using this alpha? Sorry, using this 0.005 that we have got. Will we move in by looking at this? Like what we need? We need to find the Z value, no? Okay, we have the area. Like these values, these all values, okay, represents the area, and this represents the Z value. So 0.005 we will find, no? 0.005, but where is 0.005? Let's see. 0.0045, 0.0059, 0.0059, C, 0.0049 and 51. So any of these value we can take, 51 also or 49 also. Let's take this 51. So what will be my Z value? Negative 2.51, okay, plus 0.08, है ना? Okay,
So it's 0.7, sir, for
0.7.
5-1. 2.5 and the above value is 0.7, I guess.
Okay, okay, okay. Say it's correct. So what will be this value? 2 point negative 2.57. Okay, the Z value corresponding to this value. Okay, we have got negative 2.57. Is it 57 only? 2 point, yeah, 2.57. So now we have got the Z value. Okay. So what do you think? This Z is this value 2.57? Is this value 2.57? Is this correct? Is this value 2.57? What is this 2.57? Okay, like if we convert this normal distribution into standard normal distribution, you know, okay, then okay, you know, what we are doing, we are just changing the scale of the x. We are changing the scale of the x. You know, here mu was 9. Okay, now what I am doing? I am doing x minus mu by sigma. So 9 minus 9 by sigma will do. So it will shift to 0. Okay, so in the standard normal distribution, okay, this will be 2.57. This value is belonging with respect to the standard normal distribution. Okay, So that is what is happening. So like we will put this, okay, value over here. Let's put this value. So can you tell me what is the value that is coming? 9 plus minus negative 2.57 into sigma. What is sigma? Sigma is zero point 0.8, okay, and n was 36, so root 36 will be 6. Okay, now could you find what is the value of this? Could you find what is the value? 2.57 into zero point 0.8 divided by 6. So it is plus minus 0.34. So 9 plus minus 0.34. Okay. So this value, okay, this test value, okay, the test from this test data set, okay, that came out to be 9.3. Okay, but uh, my region is from, okay, 9.9 minus 0.34 to, okay, 9 plus 0.34. Okay, so 9.34, and this will be, let's say 8.7. I'm taking the average. So what do you think? Here my null hypothesis is accepted. Is this value lying within the within the critical values? Okay, so this will be my lower critical value, this will be my upper critical value. So is that lying inside that? Like, is the sample data lying within this critical values?
Yes, sir.
Hmm. So that means what we will do?
We will accept.
Hmm. We will accept the null hypothesis. Okay.
Sir, for the above formula, should we take the sample mean or the population mean, sir?
This is population mean. See, why we will take population mean, not the sample mean? Okay, why we will take for the population mean? Because like I need to be confident, okay, with respect to my null hypothesis, है ना? Like null hypothesis says that it is 9, but in reality it will not be 9. It will be differing. Okay, it will, okay, it will have some error. Okay, so like that is why we need to find on the population, on the not the sample mean, no? So let's see, like one more method. This was a critical value. Using the critical value method we found this. Okay, now let's find using the p-value method. Okay, let's find using the p-value method. Now all the steps will be same, no? Null hypothesis, stating the like hypothesis, this is same. Okay, see, this is also same, like selecting the significance level. Okay, now in the third region, finding the test statistics. Okay, in third region I will, okay, I will make a change, you know? In the third region I will find the calculate test statistics, you know? So what will I do? I will find the z value. Okay, z or test, z test I will find. Okay, this z test formula would be now x minus mu, okay, sigma by root n. Okay, why I have written this x bar over here? Because I am finding with respect to my sample, you know? Test statistics is done on the sample, you know? So using this we will find this value, you know, this z value, x bar minus mu whole upon sigma by root n. Okay, so after finding this, can you tell me what will we do? So this will come out to be 2.25. So after finding this, can you tell me what will we do? Like we have found the test statistics, है ना? Like what does it tells? Okay, see, like this is my distribution, है ना? So what it has found, like with respect to my like these are my critical okay critical values, and okay, this is the region where I will be rejecting, you know, my null hypothesis. So it has found the z value corresponding to this, है ना? Corresponding to this it has found. Now what will I do? I need to find this area, this area. So okay, this area is known as the p value. So can you tell how will we find this green region? Now I have the z value with me, no? I need to find the area. How will we find?
So using the table, we get one
Mm-hmm.
value. We have to
Mm-hmm.
subtract that from 1.
Mm-hmm. So how will we find negative 2.2, okay, 2.25? So it is coming 0.122, 0.0122. Okay, so this will be my p value. So did you got how I, like you were correct that we need to do 1 minus, okay, uh, the value that we will get from the table for that particular z value. Okay, so z value was 2.25. Okay, but instead of that I can do this also, na, because this curve is symmetrical. So for this 2.25 I will find the area with respect to negative 2.25. Okay, so this area will be equal to this area, you know? Like, are you able to understand this? I didn't
Okay, you
find.
divided it by 2.
No, I didn't divide by 2. Like z was 2.25 now. If I would have found 2.25, I would have gone in the plus part, no? 2.25, you know? So like let's see what is the 2.25. 2.25 over here is 9946. 9946, you know? So this is the value for 2.25, you know? So so from this if I will subtract this one, you know, then I will get the answer. But like this is a long step. Instead of this, what I will do, I will find the negative of that z value. I will find the negative of that z value, you know? And for that z value, if I will find the area, you know, that area will be equal to this area.
So your screen.
Is this thing correct? See, like this curve.
Sir,
Yeah,
sir, like what is the difference in finding for negative z value and positive z value, sir? Both are symmetric, no? So we can subtract from one.
mm-hmm. Yeah, you are right. But why I am taking the negative z value? Like if like you can find that using like subtracting one also, that is not a problem. But I was telling you that instead of subtracting this one, you can directly find the value, okay, of the negative of that. If you find the value on the negative of it, then directly you will get the value, you know? So like let me try to explain you. And like if you will find over here, you know, then from the z table you will find this area, है ना? From this area you will subtract 1 and then you will get this area, है ना? As we know that this curve is symmetrical, if we go from this to this side, है ना? If we go to negative z, है ना? Then this area will be equal to this area. Do you agree with me? Because this curve is symmetrical, है ना? So this area will be equal to this area. Do you agree or do you don't agree?
Yes, sir.
है ना? So instead of subtracting it from 1, I could have found the z value with respect to like negative of it. Then we get the value from the left part, na? Left to that z, we get the area, na? So that's why like we can find the negative also, so it's not a problem, na? Now I have got, okay, the value that is 0.0122, na? And the significance level was 0.01. So can you tell me whether I should accept the null hypothesis or reject? Alpha is this and p value is this. Yeah, what was the definition of p value that I told you? Do you remember? I told you, na, that p value is the evidence that my null hypothesis is true. Na? So here what is happening is p value more than alpha. If p value is more than alpha, then what will I say?
Null hypothesis is accepted.
Okay. Yeah, correct. Na? More the p value, more the chance. Okay, if p value is more, okay, more the chance that my null hypothesis is accepted. You know? So like that is the way we do hypothesis testing. Okay, so one method is doing the critical using the critical values method, and another method is using the p-value method. You know? So I hope that you would have understood both the methods. You know? In one method, we will be finding the critical value, okay, in the second step, you know, using the critical value method. But in like this, using the p value, I will be finding the, okay, the I will be doing the calculations, okay, in the test third part, that is the test statistic. You know, here I will be like using the formula. Earlier I was using the formula on the second step. You know? So like that would be it in this like hypothesis testing. Like, do you have any doubt uh, in
Sir,
this?
actually,
Mm-hmm.
yeah, we have done using two methods, no, sir. This
Mm-hmm.
critical point and using the z value.
Using the
The
p
second
value.
method is,
P value.
yeah,
Mm-hmm.
yes. The second method is fine, sir. But
Mm-hmm.
can we discuss the coding part of the first method?
Coding part.
Because we have taken, yeah, because we have taken the mean two times and yeah. So can we discuss the coding part?
Okay. Like coding part. Like like that will take another session, है ना? Because like in that, what have you not understood? Like one question that you are asking, that we have taken the mean two times, है ना?
Yes, sir.
Okay, so no problem. I'll discuss that tomorrow, you know, because the thing is that if you are like, you don't need to focus on that coding part. Okay, that is like just a like you don't need to like focus on that coding part. The important thing is like how do we do the testing and all, you know. And regarding the question that you are asking me, that why I took the like mean two times, basically like what is happening, that I want to find the, like this is my population, you know, this is my population. I have some points over here. So for the population, what is my mean? Okay, so that we call it as mu, no? We call it mu, you know? So that's why we found the mean for the population. One time was this, and another time was for the sample. So can you tell me, am I able to find mu in real life? Am I able to find that? Like, is it that easy that we just take the mean and we find the actual mean? Are we able to find the actual mean of the population? What
No,
do you
sir.
think? Yeah. Okay. But in the coding part, what happened? I found the actual mean. And why I was able to find the actual mean? Because I was having all the values. You know? So that's why. That's why this part, for this part, I found taken the average. But in real life, what happens? I only have the samples. Okay. I have an assumption that this mu is the mu for the actual population. This is the assumption. You know, this is the null hypothesis. But okay, I want to test this. So what will I do? I will take a sample, and from this sample I'll again find the mean of it. You know, I'll find the mean of it. Then I will be comparing, I will be doing the test between the population mean and the sample mean. Okay, so that we will do using that critical value method and p value method, you know. So like that would be in this, because the thing is that if we discuss these things, it will take a lot of time. I think that like the coding part we can discuss separately in a separate session. So like, are you ready for that? But for that you need to be like present in the morning. So will you be available in the morning? Because in the regular timing I'm thinking that I should focus on the the like question answer part, you know, because Sudanaka was saying that like we should prepare the session as per the question answer, like we did for the that linear regression. So yesterday I was planning to tell you the important questions for logistic regression, you know. And if you want to discuss the this coding part of this, so in morning, will you be available in morning?
At what time, sir?
Like at any time you tell me, because in morning I can take out some time and then tell you.
Okay, sir. We will discuss and let you know.
Okay.
And also, sir, that in the
Mm-hmm.
doubt I asked before for
Uh-huh.
calculating the upper critical value and lower critical value.
Uh-huh.
Sir, when we were writing the code, there also we have used the this sample mean, sir. We didn't use the
Mm-hmm.
population mean. That's why I got confused. So I just want to get a clarity which one to use if we want to
We,
calculate the.
okay, there we use the sample mean.
Yes, sir.
Okay, okay.
I
Yeah,
mean,
then.
as far as I know, we use the sample mean, but you
Mhm.
just check and just let me know, sir.
Okay, okay. Okay, okay, sure. I'll let you know regarding
Yeah.
that. But like I'm 100% sure it is population mean. It's not the sample mean. Okay. Maybe like I could have told you wrong. I'll check you and I'll tell you about that. You know?
Okay, sir.
And regarding the like coding part, like you can discuss with yourself. And in morning, before 9 I am available. So before 9 you can like tell me anytime. Okay, for 1 hour I can take the session. Okay.
Okay, sir.
All right, students, so that would be it in this session. Thank you all for participating, and we'll be meeting tomorrow. So bye bye everyone.